Hi, everybody. This is Tor Storley, and I am back after some time off. I decided I would like to do the continuation of the SQL Server Geospatial series that I started. It's now a year later, and I apologize for not continuing with those, but I've been very busy working as a data engineer in a large enterprise, and therefore I had to spend most of my time trying to get up to speed on all the ins and outs of working with Spark, etc. But now I'm back, and I thought I'll like to continue where I left off. And what I like to do is first start with how you can obtain shapefiles for free, and maybe how you can manipulate shapefiles, prepare shapefiles, so you can actually consume it into SQL Server. And from there, we'll continue with how you can manipulate in SQL Server and potentially create reports. So let's get started. So what I would like to start with is to go to some places where you can get free shapefiles. One of the most used shapefile here in the US is the Census Bureau, because they provide all kinds of shapefiles. There's shapefiles that covers regions like zip codes, CBSAs, counties, states, etc. There's also roads, water areas, and all kinds of shapefiles they provide. So let's take a look and see what's available. So the first thing you want to do is get to the US Census Bureau, and they offer something called the Tiger files. So when I search for the Tiger files, I hope it helps to be on the internet. So let me quickly connect. So when you go to the US Census Bureau and you go and search for Tiger files, this is where you're going to end up. And the beauty of it now is that according to this website, they have actually updated the Tiger files. So now they have the 2020 Census Bureaus already finished. And that happened as of February of this year, which is 2021. So right now, you should be able to find Tiger files that are drawn up based on the US Census Bureau's 2020 survey. So if you look at this, we can go in and get some shapefiles. So what I'm going to do is I'm going to scroll down here, and you can see there's all kinds of documentations that explains these shapefiles. So let's go and see if we can actually get some shapefiles. So I'm drilling in here to the shapefiles, and then I'm going to open this web interface link, and I do it over here. And then you have a list of all kinds of data you can download. So one thing you might want to consider, depending on what you're going to be doing, there are roads, rails, military installations, water, etc. Thing that in the past that I used to work with was to create representations on a map for Salesforce. So a Salesforce covered a certain area, and depending on how granular you want to get, we could use zip codes. There could be CBSAs that would cover certain areas. If your Salesforce cover counties, that would be another one, and states, etc. So for now, you can pick whatever you need to pick, and then we'll take it from there. Now, if I want to pick, I could pick these counties. That would be one I would download. States will be another one. And this zip code tabulation area would be for zip codes. And there's also these core-based statistical areas, which is basically the CBSAs that I've been talking about. So anyways, I'll leave it up to you how you want to do that. You choose what you want, you click submit, and then it will take you to the download page. So if I choose this, you just click on whatever you want to download. So that's how you obtain the Census Bureau's files. So make sure you check out all this documentation so you're fully aware of how this is created. Okay, so now we have downloaded the shapefiles, and I have downloaded them and moved them over to my folder here on the Geospatial. And if you look at these files, they're zip files, and you can see here, these are what I ended up downloading here, all this 2020 zip files. Some of them are very large, so be careful, because this zip code is half a gig. So that's a lot of data. So if you don't need it, maybe you should avoid downloading this file. One thing we can do in order to view this, SQL Server is good for certain things, but it's not the best way of looking at shapefiles. So what I do these days, I try to obtain some free tools, obviously, like everybody else. So I downloaded this Qgis, and this Qgis is a free software that you can donate to, and it's created by some very clever people. There's a lot of them contributing to this project, and it has tons and tons of functionality for geospatial manipulation. And this is what it looks like. It gets updated very often. And if you look at the help for this particular tool, they have all kinds of help files here on the internet. And there's also a, let me see if I can open it again. There is also about here. So if you go to the about, you can see there's all kinds of versions that has been created. Don't sit too long on one version because they constantly update this. And they tend to name these versions after cities. I've seen a lot of European cities, so maybe there's a lot of people contributing from Europe, because the latest one that I have is Zurich. So you can see here 3.18 is the latest version. And there's a lot of information about what they're providing and the all kinds of plugins. A lot of this are Python scripts that they providing us with. You can see here quite a bit of people involved. So make sure you help them out and donate to them. You can see here the license and so forth. So anyways, this tool is a great place to start, so you can actually work on your geospatial information. So what I'm going to do is I'm going to expand on these files. Just so you get an idea, I'm going to grab this state file and I'm going to just drag it in here, and then get prompted like this. What I'm going to do, I'm going to create from the shapes the extension SHP. I'm simply going to select that and say OK. So now it asks me to do a conversion. The shapefiles that the Census Bureaus are providing you with is written in a projection format called NAD83, which is North America Datum of 1983. However, the most used datum for representation of shapefiles on the browsers, if you will, like Google Maps and Bing Maps, is this Qgeis 84. This is the one place you could convert it into that format. So right now you say convert NAD83 to Qgeis 84. So let's say OK to that. So here you can see now, here's all the states that came from the Census Bureau. And you can see over here, you can do all kinds of styling, which is kind of cool. There's a lot of hidden gems in this software, but I'm not going to focus too much on the software because I don't know enough about it, and therefore I can't really guide you through all of it. I have experimented a little bit, but I don't know very much about it. But I know a couple of things that I can use. You can click on this ABC up here, this button, and then over here on the right-hand side, you can see there is single label is one of them you can use. And now as you can see, it provides you with the actual labels. And these are the fields you can use as labels. So you could use here where you get numbers. So for example, Illinois, where I'm residing, is 17, for example. So you can do divisions, and you can do regions. So as you can see here, it provides you with all these different type of labeling. So that's one thing you can use to open your shapefiles in this Qgis. Now we got a representation of the states in the US on this Qgis tool. Some things we can do here, we can manipulate all kinds of shape representations in here. If I don't want to see all these states, maybe I want to hone in on my home state of Illinois. By the way, there's all these panels here does different things. Like here you can navigate if you look on the left-hand side under the browser. And of course you can go view and select whatever panels you want here, like the browser you can see over here. To me, it's a little confusing sometimes because I get lost in this. But if you look over here, you can navigate to files, and you can also import shapefiles from different databases. As you can see, there's PostGIS, SAP HANA, there is a MS SQL, which of course is SQL Server. So if I look at that one, you can see this is my 2019 instance. And if you look at the databases, you can look at only geospatial data, like you see here. You can also say show non-spatial tables as well. So that's possible. You can see all the data. So Oracle is represented in here. Of course, you can drill into your C drive and get the shapefiles and so forth from there. So that's this browser tab. If you look down here, I got a layer, which is this US states. I can right click on this and I say, hey, I want to duplicate this layer. So now I got a copy of it. So I can uncheck this and check this. So here's a copy. So maybe what I want to do is only bring in Illinois. So what I can do, I can use a filter, and this opens up. And if you remember, there's region is a number, division was a number. I said that the state FP was 17 for Illinois. So I can filter it, according to how I want to hone in on this. If I want to see Wisconsin, Illinois, Indiana, and Michigan together, is basically go into this state FP. And now I'm getting the numbers because it's easier to work with numbers than typing in a bunch of text. So if I look at this, you got 55, 17, 26, and 18. So I can go to filter. I can double click on this, and you can see it comes in quotes. One thing you have to do is whenever you refer to these guys, they're treated as text, so you have to put in single quotes. Since I want 4 of them, I can use SQL-like queries. So I can say like or in. So what I want to say is, I want to say in, and then I put in parentheses here. I can say, all right, I want it to be Wisconsin, so that's 55. I want 17 for Illinois. I want 26 for Michigan. Put in single quote. And I want 18 for Indiana, right? So 18. Now I can test it. There it is. So you can see it's filtered out those because of my in clause. If I only want Illinois, I can simply say equal to 17, like this. Test that. And now I got Illinois. So I want to keep that. I want to only keep Illinois here. So I got this layer here of Illinois, and then I want to maybe rename it. So I can go to rename layer. I can call it US 2020 IL, something like that. So here is my Illinois. I can export this. So I say export, save features as, and it prompts me with some information here. So I'm going to save it as an S3 shapefile. I want to call it US 2020 IL. And then it has the coordinate systems here. So you notice it's 4269 is NAD 83. So that's the North American datum for 1983. That's not the way I want to save this. I want to save it as WGS 84. So I'm going to choose WGS 84, which is 4326 as a SRID. And that's fine. And I will save it like this. So first of all, I need to put it in the right place here. So I'm going to navigate to, instead of my documents, I can probably put in my temp folder somewhere, just so you, because this is just an illustration. And let's put it under, I don't know, plots maybe. I already have one there, so let's get rid of that. So I'll save it there. And I say, okay, move this. And there it is. Now it's saved here. So when I go there, I have all this information. And notice I got the DBFs and everything in here. The projection, everything is in here. So let's go and check the projection. Notice it was saved as WGS 84. So that's exactly how we wanted it to be saved. So now we got a shapefile with some information. You also got a DBF, which is basically all this information about Illinois, and you can see it here. So, all right. So now we got a starting point for start working with different formats within this Qgeis. So now I got these shapefiles. So let's do this. Let's get rid of all these files that I have on my screen here. And I'm just going to remove them. So the remove layer. So now all three of them are gone. So what I want to do is I want to take that file I just created, and I'm going to grab the SHP version here, and I'm going to drag it over as a layer here. So now I got that file set up. I want to go to one of my other files. So remember I downloaded these from the Census Bureau. So one thing I want to do is I want to see how many of these zip codes will fit in with Illinois. So I'm going to drag the zip code over. I'm going to deselect all and select the shape version of it. So now you see it gets pretty busy because there's a lot of zip codes, and this is a national file. So it puts all the zip codes for the whole of US here. And one thing that is not represented in the zip code file, if you go and open the attribute table, you can see here there's no reference to any state. So that makes it kind of difficult to figure out, well, which one of these zip codes are in Illinois? Well, one thing we can do, we are interested in all these zip codes that fits within the shape of Illinois. So we can use one of the built-in functionalities that comes with Qgis. If you go into the vector menu, there are geoprocessing tools and there's geometry tools. If you choose the geoprocessing tools and you go to intersection and you choose the state as an input layer and the overlay layer, we want it to be the zip codes. Now this might be a little time consuming, but we're going to run this. And for anything that Qgis is typically produces an output layer, a new output layer. So it's processing the whole information, and keep in mind there's a lot of zip codes to try to figure out which one fits within Illinois. Okay, so task complete. Intersection is completed, and we can close this. And if you look now, there's this intersection layer that was created, has a different color. So we can uncheck the other two. And now we have all the zip codes that fits within the Illinois state file. And of course, we can go here and choose labels and choose single label. And if you look here, there is a lot of fields. That's because we picked up all the state fields, as you can see here, but we also picked up the zip code fields. So what I can do is I can go to this ZCTA A5CE10, for example, and click on that. And if I drill in, you can see here is the zip codes for that. So now we got zip codes. We got a bunch of labels. So perhaps what we want to do is we might want to rename this, right? So you could rename it, and we can call it US 2020 ill zip or something like that. I don't know. So we name it that, and we can also export. And keep in mind, the nice thing here when you do the export is that you can choose. So if you look here, you have all these fields, right? Maybe we don't want all the mix. You might want to keep maybe the state. So perhaps you only want the state number, and maybe you want the name. So you have this. Maybe we'll take out the geo ID. There's all kinds of stuff here. And basically, we want to keep the zip and some of the fields here. So let's go with this. And then we can export this. We'll give it a name. So let's call it US 2020 IL zip, right? Something like that. And let's save that. And we want to save it as WGS84. So let's save that. And there it is. So now it's done. So we can open that folder over here. Let's get rid of all these layers. Remove layers. Yes. And let's go to our file and let's drag in this guy so we can look at it one more time. And there it is. So now we created shapefiles of zip codes within the state of Illinois. Okay, so now we got some zip codes overlaying the state of Illinois. Another thing that might be interesting to look at is if I open my files here, and there is also a county zip file that we downloaded. So let's drag that one over here, and let's deselect everything and choose just the shapes. Say OK. And yes, we're going to use Qgeis 84. So now you can see the whole thing gets overlaid here. However, I don't want all these counties for the whole country. So the first thing we can do is to basically filter out. And the county files also has an attribute called state FP. So if you recall, the state of Illinois is 17. So let's filter this and see what we get. 102 rows, that looks about correct. Say OK. So now you can see we have the counties filled in here. However, this is overlaying the zip codes, because if I remove this, you can see all the zip codes are shining through here. So the first thing we might want to do is let's put some of these labels on again. So for this layer, the zip code layer, I'm going to say choose the zip codes, and this particular field I think is the same as the GeoID, so I think they're both the same. So we leave it at that. That's the zip code. And then we have the other one. So let's select that and let's go and add the label for that one as well. So now we got single label, and here we got the name. So when you look at this now, you can see here is Will County, here is Kankakee County, and down here you got the Champaign, all the counties, as you can see. And right now you can only see the labels coming through this layer because the zip code is hidden behind this layer. If you kind of want to see them, you know, what it will look like, one technique you can use is I want to keep the counties in the background. So I'm going to drag it up like this. So now the counties, the green colors you see, it is in the background, and the zip codes is in the front. However, you don't really see the counties or anything. We can leave the county where it's at, and then we can go to this zip code, right-click and go to Properties. And when you go to Properties, choose this symbology here on the side of the left-hand side of the tabs there. And then there is an opacity you can select. So right now it's red. Let's make it, I don't know, let's make it orange or something. Then we can have a gradient fill if you would like, or you can choose simple fill. Then we can just drag this. So let's say we drag it down to maybe close to 15% or so, something like that. Now we click apply, and suddenly now you can see they're shiny. They're kind of faded a little bit because the county lines are a little harsh. So let's go and fix that a little bit too. There we go. So you double click and you get into this properties. And what I want to do is I want to say fulfill, and then I want to choose the stroke color. I don't want it to be so dark, so I'm going to soften it a little bit. Maybe like this. Say OK. And then apply it. And now you can see it's a little softer. It's not so dark. It's a little more grayish now. So what we can look at now is a couple of the other features that are in this tool. So what I'm going to do for simplicity, I'm going to remove this zip codes layer. So I'll remove that. So now we're left with the counties. And I want to make a duplicate layer. So I have a copy. And then based on this duplication, the layer here, we're going to do use some of the functions that you can find in this QGIS tool. if you look at these counties, there are a lot of details around like the Mason County here. As you can see, there's a lot of jaggedy kind of drawings here. So one thing you can do, and this is often the case for reporting purposes, for optimizing speed of rendering on a Bing Map surface or Google Map surface, where you create your own files and overlay them. So one thing you could do is try to simplify some of this. If you don't care of the exact rendering here for these counties, we can go into this vector menu. There's something called Topology Checker. The Topology Checker, you can configure it like this, and you can create rules. So you can say, choose the copy of that layer that we said. Must contain, must not have duplicates. So you can do all these settings here and add those rules, and that's what you can execute. So before we do that, let's look at one of the other functions. Notice there's a geometry tools and there's geoprocessing tools. So one thing we can do is to simplify the shapes. And you might recall this, I talked about this before. You simplified the drawing of the shape by choosing lesser points. So if I say simplify here, you have to set a tolerance. So if I say, oh, I don't know about counties, but let me try something, 0.08 or something. And we're going to use this simplification method called Douglas Pucher, as you might have recalled, we talked about before. So let's run this, and it runs quick. And notice how, okay, that was a little overkill. That's a little bit too simplistic. So notice I created another layer here. So let's just get rid of that and try it again. It was a little bit too much. So let's remove that layer and let's try it again. So we'll go here, and then we say vector, geometry tools, simplify. This time, let's do a 0.005 degrees or something like that. Run that. Okay, it's done. Close it. And now when you drill in, and we're getting into Mason County, for example. So notice here, if you zoom in enough, you're going to see gaps start occurring here. So you can see it's been simplified. And what happened is that there might be overlays, like here it looks like there's a little overlay here, and there's gaps. So because we simplified it. So obviously, in order to use this, you might have to fix this a little bit more. Another thing is it's kind of zigzaggy, jaggedy kind of here. You might want to try to smooth it out. Another function you can use for that is go to, actually, you can search for it over here. So if you just search for smooth, you can see there's the function. So when I click on this, I'm just going to leave it the way it is. Let's just run it and see what happens. Okay, so it ran. There are all kinds of parameters you can set here, but I'm just playing around with this. I'm not really trying to do a professional job here. If you scroll out now, you can see that it's a lot more rounded now. Some of those harsh edges are kind of smoothed out a little bit. But as you start doing this, you're getting into altering the geography and everything. So you can do like a topology checker. So you configure it by clicking this little right-hand button. What I can say is choose the smoothed layer, this one over here. And what I want to say is must not have gaps. I want to add that rule. And I can also say the smoothed layer must not overlaps. Okay. And we can say okay to that. And when I say okay now, we have created a rule. Then what we can do is we can validate it. And notice it comes up with all the problems. So you can see here, tells you here's the gaps, here's the overlaps. So it kind of runs through it and figure out where it needs to be filling in stuff. And then you can run the check here. And as you can see, now it's filled in where all those gaps and overlaps are. Now, there is a couple of ways I think you can be able to basically snap these in place. I have not been successfully doing that myself, but there is, let me see if I can find it here. So if you search for this particular library, you can choose this vclean function. So if you go there and you take a look at it, There is some information about what this does, and you should read this. Another thing I came over was that there is actually, let me see if I can find it, an article written here, how to clean topology errors in Qgis. So you might want to check out this one too. It's geodos.com 2017 10 how to clean topology errors in Qgis. So there's some written information, although they, in this article, it doesn't really do polygons, but they do some lines here. So as you can see, they're trying to snap these lines so they connect here, and they move these lines so they connect here. So there are methods like this you can use to try to find how to actually do this. And one of these articles here too kind of tells you how this is supposed to work. Here you can see it finds the points here and then it snaps it in place. So technically speaking, you should be able to do this, but I have not succeeded in trying to do this myself. This is typically the worst thing when you're trying to create shapes like this, to kind of put them back together again. That's the hardest part. You typically need a professional tool to do that. But if you can make this work, that would be something you should let me know how you did it. So in other words, we can go to this V clean. And if you run that, it will look something like this. And there are some settings you can do. Notice that point line boundary, centroid area, I guess just leave them the way they are. Like I said, I'm not super familiar with this Qgis. Yeah, like I said, I'm not familiar with how to set this up properly. And then, you know, when you're ready, you run it and it will do a lot of stuff. But when I run it like this, it's not going to work. So I just know that. So it says it's done running. You know, nothing has really get fixed, but it's supposed to fix it. So you might want to try something like that if you want to try to simplify your shapes.